All right, so you guys did this. You added all of them up. And you divided by, what'd you divide by? Why 10? Because that's how many you have. Great. And what'd you end up with? 41.6. That is your X bar. Your sample mean. X bar equals 416 over 10, 41.6. Okay. Shove one more decimal place, then your data is in. Median is the midpoint of the array. It's the data value in the very center. So how do you find it? First step, take your data, put it in order. Once you put your data in order from least to greatest, then find the number in the middle. If you have an odd number of data values, then there's just one in the middle, and that's your median. If you have an even number of data values, you can have two that are tied for the middle, and you average those two. So I'll show you a couple examples there real quick. Here's the first one. Bless you. Police officers killed. So here, first put your data in order, so you can find the one that's numerically in the middle. Not the one that randomly happens to show up in the middle, but the one that's numerically in the middle. Put them in order. There's an odd number, so there's just one in the middle. That's the median, 157. How do you know? I usually do this. I go, okay, 3 this way, 3 this way, 2 this way, 2 this way. Oh, one in the middle. That's my median. Simple as that. Now, tornadoes. Again, put them in order, and then kind of count over. 2, 2, 1, 1. Oh, there's 2 in the middle, tied for the middle, so you have to average them. Right? Add them up, divide by 2. So the median number of tornadoes is 810. You guys do the median part on lab problem 1. Quickly. So what's the first thing you do? Put them in order. Take your data, put them in order. Smallest to largest. It's not which one happens to randomly be sitting in the middle, it's which one is numerically in the middle. Right, you have to write them in order. 27. I like to cross them out as I go so I make sure I catch them all. Or, that way if I know if I miss one, I know where to put it in. Once you get them in order, find the one in the middle. 3 there, 3 there, 1 there, 1 there. Oh, look, there's 2 tied for the middle. If I average 43 and 43, what do I get? 43. Good? Okay. So your median should be one number, the average of the 2 in the middle, or if there's only one, the one that's in the middle. Mode. Do you guys need 30 seconds to talk to neighbors about this? Are you guys chatting about other things? Okay. All right, Armina, go ahead. Read the next one.
The mode is the value that occurs most often in a data set, and sometimes that is the most typical case. There may be no mode, 1 mode, 2 modes, or many modes.
Good. Keep going. Well, unimodal is 1 mode. Bimodal is 2 modes, or multimodal would be many modes. And mode is the one that occurs the most. So that's kind of another way that people kind of remember that. So here's an example. Sometimes it helps to put them in order because it's easier to find what they are, but you can clearly see 10 occurs the very most here. So there is one mode, 10, right? Everybody on board with that? And then here, if I look at this, there are 5 of these, and there are also 1, 2, 3, 4, 5 of those. So they're both tied for the most. Since they're tied for the most, it has 2 modes, 104 and 109. Please note, if I had one more 109, then 109 would win, and there'd only be one mode, 109. But because they're exactly tied, they both have exactly 5, then it's bimodal. Do the mode part on lab problem 1. I'll give you guys 15 seconds to find that. Which one occurs the most? All right, which one occurs the most, guys?
Mode.
Yeah, 43. 43 occurs the most, so the mode is 43.
On that.
No worries. You got it now?
Yeah.
Okay. It's all good. Mid-range. The mid-range is the average mid-range. Do you everyone see the word mid there? Does everyone see the word mid?
Yes.
Mid, whenever you have a mid, you're going to average the top and the bottom. It's the one in the middle. So anytime you have something in the middle, you're going to average the top and the bottom. Here it's the mid-range, so you're going to average the range, the top and the bottom. So you're going to take the highest value and the lowest value, you're going to average them. That's the mid-range. So lowest to the highest. Remember I had the issue with, I talked about that in the first week of class, about how it's kind of a bad measure of average because you take 49 people who make $20,000 a year in a company, and you take one guy who makes $1 million. The mid-range is the average of the lowest and the highest, so the mid-range would be $510,000. It's not really fair to say that the average employee makes $510,000, even though mid-range is technically a measure of average. But that's the mid-range. So I'll show you guys, here's a quick sample, right? Bank failures, the highest is 157, the lowest is 3. You average them, and your mid-range is 80. So you guys do the mid-range problem on yours. And again, I'll give you guys about 15 seconds to do that. Lowest is 27, the highest is 57. All right, so my mid-range is going to be the average of 27 and 57. Add them up, divide by 2, because there's 2 of them, and you guys got 42, the answer to everything in the universe. Okay. Now we're going to do something that's a little bit tougher, something you haven't necessarily seen before. This is weighted means. So let's give an example. Honey, go ahead and read.
The mean and the median. The water temperature at a point downstream from a plant for the last 30 days is summarized in the table. What is the mean temperature for this distribution?
Great. So this is a frequency distribution. We've seen it, right? We saw it last exam. What does it mean? It means that, for example, there were 4 days that had a temperature of 56. There were 8 days that had a temperature of 55. Everybody on board with this part? These are our x values. This is the frequency, how often they occur. Now I could add up, if I'm going to average them, I have 4 52s and 6 53s, right? So the typical way of doing this would be like that, right? 4 52s, add those up. 6 53s, add those up. 3 54s, 8 55s, and so forth. Good? Add them all up and divide by how many there are. How many are there? 30 of them. Good? Everybody on board with that part? However, the point of math is to help us be lazy. So instead of adding 52 4 times, we're just gonna multiply 4 times 52, because that's the same thing as adding, that's where that comes from. Remember when you were a small child? 4 times 3 was basically adding 3 4 times. So instead of adding 52 4 times, we're just gonna multiply them and add each of those. So everybody do these with me, right? So here we're gonna take 6, so write them out, fill out this table. 6 times 53, where's your table? Should be writing it in your table. Write it in your table. And I'm just gonna write them all in first, and then I'll multiply them, it's easier.
Killing it today.
Because I'm like trying to like, she's like, you gotta be writing it.
Guys, make sure you take good notes on this. Because your notes, the number one thing that's easiest for you to understand when you're reviewing stuff is your notes. Also, when you're explaining stuff to other people, what you may need to do next semester or some other year, right? I have all my probability notes from my grad school. I can pull those notes out, and I can go over with new grad students who are like, what do I do? And I can explain stuff to them. Even though it's been a few years, if I go through my notes, because I took good notes, then I can, after a couple of minutes, I can figure out what to do and how to explain things to them. So keep good notes. All right, so this is 318, 162, 440, 224, and 250 plus 35. 250 plus 35. 250 plus 35. 285. If you add them up, you should get, yep, 1637. Great. And then, so then I'm going to take this 1637 and divide by my total frequency. My total frequency is 30. And you guys are going to get what? What do you get for that?
54.567.
567. Great. My data has how many decimal places, guys? 0. So my mean should have how many decimal places?
0.
1. 1 more than your original data is in. So 54.6. That's your answer. Please note something. To get these, you guys look up. To get these, I multiplied temperature times number of days, right? What do I want? The average number of days or the average temperature? Average temperature. Which means that I should be, if this is days times temperature, I should be dividing by days to get temperature. Does that, you guys understand what I'm saying? Here, I'll show you what I'm talking about. This is really temp times days. So you divide by 30 days. That way, the days cancel out, and you're left with temperature. Do you guys see what's going on? The hardest thing people are going to have with this is figuring out what to divide by. You're going to want to divide by this. You're going to want to divide by the number of classes. You're going to want to divide by all sorts of crazy things. The way you know is that this is this times that, and figure out what you want to find the average of. The average of temperature, you divide by the days then. So divide out the days. Divide the other one that you're not trying to find the average of. Good? Yes, question?
Are you typically for like
any chart like this gonna just divide by like the total of the frequency?
Yes, but sometimes it's unclear what the frequency is,
Okay.
which we'll see in, I think, the next example. So weighted mean on the next page. Edgar, let's volunteer to go and read.
Find the weighted mean of a variable by multiplying each value by its corresponding weight and dividing the sum of the products by the sum of the weights.
Right, so here it is here. Again, your x bar, you multiply every x value by its weight, and divide by the sum of the weights. The weights are the frequencies, so the frequency and weight are the same thing. So here we have our sum, right? Remember it's a sum symbol. Sum of every weight times its x value, or x value by its weight, divided by the sum of the weights. Where, below that, write in x bar. Did you guys fill out the first part of page 1? You should have filled those in, right? Mean, median, mode, or whatever they were. Yeah? Okay. So this part here, x bar is your sample mean, right? X is your, those are your data values. W is your weights or frequencies. And some of the weights, yeah, some of the weights is some of the weights, some of the frequencies. Okay.
So the last one, that symbol
Sum.
used is,
You add them all up. So that sum means sum. This means sum like SUM. I know that means add them all up. That's where this part comes from. That's the adding up stuff. That's this stuff here, right? When you're adding them all up. Good question. Yeah.
What's X again?
X is your individual data values. X bar is your sample mean. Okay. So, let's talk about this one a little bit. I'm going to kind of let you guys sort of do it on your own, but I'm going to explain something to you first about this one. So, here, I don't know if you guys realize it, but the way that grades work for GPA is that some classes are more units than other classes. Like this is a 4-unit class. So it's weighted more than, say, a 2-unit class. Your grade here counts twice as much as a 2-unit class because it's 4 units. It's twice as many units. So really, that see where it says 3 credits there? That really means, think of each credit like a small grade. So really this person has 3 small A's, right? Because it's a 3-unit class. Is that you guys kind of following me? And this one here, there's a 3-unit class, so it's really like 3 small C's. And here's is a 4-unit class, so it's more. It's like 4 small B's. It has more weight. It has 4 of them because it's a 4 there. Here's this is less weight. It's like 2 small D's because it's only a 2-unit class. So these smaller units will have means you really have less of them. So you guys are all familiar with weights. A's are worth how many points? 4. This is like having 3 4s. And this is like having, C's are worth how many?
2.
Yep, 2. 3. So it's like having 3 2s. The B is like, I should do this in 2 colors, sorry. Just realized. And the B's are worth 3. And the D's are worth 1. So it's like having all these numbers, 4 4, 4 2 2, 2 3 3, 3 3 1 1, and averaging them, adding them all up and dividing how many there are. You could do it that way, totally. But again, math should help us be lazy, so we're going to do our whole little this times this, which is just a shortcut for being able to add them. We still need to divide by how many there are. All right, so why don't you guys take a few minutes with your neighbors and compute the GPA. Okay, let's take a look. easy way. 3 times 4, 3 times 2, 4 times 3, and 2 times 1. So 12, 6, 12, and 2. You guys got 32. All right, so here's the hard part. You have your 32. That stands for credit times grade, right? That's how you got that? That's what it is? What do I want? Do I want the average? Do I want my grade average or my credit average? Grade average, grade point average, right? So we want the grade average. So I should divide by, I want to keep that, I want to get rid of this. How do I get rid of this? I divide by credit. Is that, you guys kind of follow what I'm saying? So I need to divide by my total number of credits. What do I have? 12. So I divide by 12 credits. That way these guys cancel out and I'm just left with grades. My average grade. So this ends up being, what did you guys get for this? 2.67, is that right?
Yes, ma'am.
So you can do, so GPA is weird. We should round to how many decimal places? 1. GPA people typically do 2, so I will accept either this or 2.7. Either is okay in the GPA case only because GPAs are typically done with 2 decimal places, just because they're weird like that. Okay, here it is prettier. Okay, does everybody understand this? Because we got to take it one step further now. Okay, do you guys need 30 seconds with your neighbors? No. Okay. So here, we're going to take a look at classes. So my question here is, what do I do? Here I have a group frequency distribution. Do you guys remember these? You guys did one on the exam? I have a class 130 to 149. What's the best number? I can't use a range like that. I have to use a number. Which number should I use? Should I use 130? Should I use 149? What's the best number to use for that?
The midpoint.
The midpoint. Is everybody with me on that one? Because it's the least likely to be, it's kind of the best typical answer. Because if I picked 130, then if I had 149, I'd be really far away. If I picked 149, then if it was 130, I'd be really far away. If I picked the midpoint, then it can't be more than halfway either direction from the actual data values. You know what I'm saying? It minimizes the badness that it could be, the inaccuracies. So we're going to use the midpoint. So here, everything else is exactly the same. You just find the midpoints, and then you do the same thing you've been doing. The frequency times the midpoint, right there. Add them up, and again, divide by the total frequencies. Is that everybody kind of on board? So in other words, I'll take 1 times its midpoint, 139.5. I'll take 7 times its midpoint, 119.5. I'll do that for all the classes, add those up, and divide by my total frequencies. And that will give me my average. Here it is in steps. I hate it in steps because I just hate memorizing procedures. I think this makes more sense than memorizing procedures, but if you like memorizing procedures, here they are. Make your table, find the midpoints of each section, multiply the frequency by the midpoint for each group, and then add up column D and divide that by the sum of the frequencies. So you guys do lab problem number 3. So spend 3 or 4 more minutes working on it, and then when you're done, you can take a break until 23 after. Find all your midpoints, and then find the
So like you add it, divide by
let's go ahead and get started. Oh, yeah, sorry. What did you guys get for this one? Sorry. Okay. Okay, so for midpoints, what did you guys get for those?
8,
8,
13,
and then 13,
18,
18.
23.
And you notice, how do I figure out what my class width is? You guys remember how to find a class width? You take, yeah, two consecutive classes. Their upper boundary, their lower boundaries, their lower limits, or their upper limits, or their midpoints. So here, you subtract these two, and you see they're all separated by 5, right? So once you find a couple, just add 5, add 5, add 5, you get the rest. So 23, 28, 33, 38. All good? And then Armina, what do you guys do next?
You total it out.
I add up these.
No, honestly, I wasn't. Oh, multiply by frequency?
Yeah, multiply by the frequency. So this becomes 8, 26, right? You're going to multiply these two. 54, 125, 115. 4 times 3 is 12, 99, and 76. And then you add those up. What do you got? What did you guys get when you added them up?
490.
490. Great. And then divide by your total frequency, right? Because this is, that's what we're looking for. So 490 divided by 20, and you got 24.5. Yes?
Yes.
Great. All right. Here it is prettier. Oh yeah, 24.5 miles.
Real quick, could you explain again why you divide by frequency?
Yeah. All right, so really, this is class midpoints of what? These are miles. Is everybody okay with that part? These are miles run. These are also miles. So really, this is 490 miles times frequency. What do I want, the average frequency or the average miles? Average miles. So I need to divide out the frequencies.
I understand.
So since my frequency is 20, I'm going to divide by, you guys, divide by 20 my frequency so that I end up with miles at the end, average miles. There are some properties of means. Megan, go ahead and read.
Found by using all the values of data, varies less than the median or mode, used for computing other statistics such as the variance. Unique, usually not one of the data values, not be used in multi-point classes, affected by too high or low values, called outliers.
Right, remember Michael Jordan, total outlier? He pulled everybody's average. So the geology majors at UNC that year had an average income of $500,000 or something like that, right? Because of him, because he was an outlier. Medians. Vanessa, go ahead.
Properties of the median gives a midpoint. Use one is necessary to find out whether the data values fall into the upper half or lower half of the distribution. Can be used for an open-ended distribution affected less than the mean by extremely high or extremely low values.
Great. Right, so again, Michael Jordan, that outlier, doesn't affect the median. It would still stay the same even with him way out there. It wouldn't matter whether he made 100,000 or 100 million. That doesn't change the median, because the median just counts how many are below it and above it. So he would just be one of them that's above it. It doesn't matter how much above it he is. properties of the mode. Alyssa Q, go ahead.
Usually when typical case is desired, uses average to compute can be used with nominal data, not always unique or may not exist.
Right, so the mode is great because when we're talking about categorical data, like shirt color or name, you can't find the average of Robert, John, Steve, and Cindy, the names, right? But you can find the mode, the name that occurs most often.
When you're done explaining this, can you go back to the slide that showed like the symbols on the frequency and midpoint weighted frequency?
Yeah, I got one more and then we'll go back. Mid-range, it's easiest to compute, however, remember that one's really affected by extremely high or low values in a data set. If they talked about, if they used mid-range for the average with Michael Jordan, then you know, the mid-range of the income would have been $5 million, right? And it's crazy to say the average geology major at UNC makes $5 million. So mid-range is a little bit worse. So you're saying you want to go back to this one
Yes, thank you.
with this part at the bottom?
Just the symbols that were on it after X.
Oh, right. Some of the frequencies. Frequency is the same as weight times x. And here, if we're talking about a class with a range, then x midpoint, the midpoint of the x's. And here we're dividing by n. N is the sum of the sum of the frequencies. N is your sample size. So this is the same thing as the sum of the frequencies. And in a sense, frequencies and weight are kind of synonymous. They mean the same thing. All right, yeah, Adam.
Do you ever just, like, is there ever a situation where you can just cut out the outliers just to use the midpoints? Or to find, like, the mid-range?
Are there times when people would, in real life, drop out the outliers? I think so. We're not really gonna, that gets a little more into statistical decisions, and it gets really sketchy, right? Because it's dropping out outliers because they're having a unintended effect upon what you're looking at is one thing, but dropping them out so you can prove a point of some sort gets really fuzzy, right? So there are some rules around that, and that's more about like designing an experiment and following through that, which we're not really going to get into right now. In this class, we're going to kind of focus more on just the how-tos and the basics of it. But yeah, that would definitely sometimes occur in life, and with obviously some rules around that. Yeah, for sure. Distributions. The normal one we talked about before, where it starts off low, comes up to a high spot in the middle, and then drops back down. Right? It's roughly symmetric, low up like a bell-shaped curve. So the symmetric, the left side and the right side look roughly the same. Good. Highest in the middle. And then we have right skewed. So in other words, there are some outliers to the right. These little tiny things out here, those are outliers. Right? Most of the data is over here, but there are outliers to the right, so that's right skewed. Here, there's outliers, little tiny, small amounts to the left. So you can kind of think of it as like, little small things are pulling it off to the left. That's left skewed. So it's not where most of the data is. It's where the outliers are, or where the small amount is. That's the left skewed, because those outliers are skewing it to the left, skewing the mean over. And here it's right skewed because it's yanking the mean. The outliers are yanking the mean to the right, even though the data. So the median's here, and the mean's getting yanked off to the right of the median because of outliers. And here the mean's getting yanked off to the left of the median because of outliers. All right, so now we're going to talk about measures of variation and range. So the range, it's the difference between the highest and lowest data values in a data set. Can everyone see the word mid here?
No.
You guys see the word mid?
No.
No? So there's no word mid here. It is not an average of two numbers. No mid. Mid means you take two numbers